Alrighty. Okay, so we're trying to find the total force, the net force on Q1, right? So to do this, we're going to figure out there's a force of attraction. This guy's positive, right? This guy's positive. So there's a force of attraction that goes this way. I'll call that F2 because it's exerted by charge number 2, right? And by the way, the angle for this thing is going to be let's see, this is 270 is straight down, right? So this is 30 degrees shy of that because this is all these angles here are 60 degrees. This is half the angle, right? So that would be, let's see, 30 short of 270 is at 240 degrees, right? Okay. And then there's going to be somewhat less of a force acting this way because this is less charge, right? But it would still be attracted to that guy. And F3, this is again 30 degrees here. Okay, and so F3 would be 30 past 270, so that would be at 300 degrees, right? So when we do the vector stuff, that's what we're going to use, right? All right, let's see, F2 is going to be K times 4 e minus 6, right? That's what micro is, times 8 e minus 6. Okay. And then that's divided by 1.2 squared. So let's see if I can do that. Let's try that. Divided by 1.2 squared. Okay. I'm getting 0.199 and a lot of sevens. 7 bar, and that's newtons of force. I'm going to store that in A just for fun. Okay, let me double check that. Yeah, I think that's right. Okay, F3 is K times, and then this guy, here's Q1, right? 4 e minus 6, and then the other one is the 6, right? Notice I'm ignoring the minus sign that's on there because I've already taken that into account, the direction of the forces. I've already figured that out. I'm just finding sheer magnitude here. Oops, that's minus 6. It cannot be lost. A factor of a million. Okay, so 1.2 squared. All right, let me go. I'm so lazy, I'm just going to barf that thing up and change my 8 times 10 to the minus 6 to 6. Okay, and I'm going to store that in B. And I've got 0.14983 bar newtons. Okay, now remember this guy's at, F2 is at 240, and this guy is at 300 degrees. Okay, so now here's the fun, right? Here's F2, here's F3, and look how good I can draw those lines like that. Wish I could do that on the PC. Okay, so my angle, my magnitude is 0.1997 bar. And F3 is 0.14983 bar, right? My angle is, for F2 is 240 degrees. This one is 300 degrees. Now I'm checking my mode. Indeed, I'm in degrees. This is so good. Okay. And now what I want to do is I want to find the x component. Okay, let's find the x of each one, right? So I'm going to go alpha A. Do I have alpha A? Times cos 240 is negative 0.998 bar newtons. All right. I'm going to store that in C. All right. And then I'm going to go alpha B. There's that guy. And I'm going to go times cos 300. Should get a small positive number. This guy's positive 0.74916 bar newtons. I'm going to store that in H. I'm just using numbers on my calculator that happen to be above each other. Okay, so here we go. All right. Okay. Okay, now let's find the y component, right? So that's going to be this times the sine of this, right? Okay, so alpha A, I've got this on my calculator, right? And I go times sine of 240. And I get negative 0.1730126 or something like that, right? Okay, and that's newtons. Okay. I'm going to store that in D just for fun. All right. And then let's find this guy. I'm going to go alpha B. I've now got this on my calculator, right? That whole number, and I'm going to go times sine 300. And I get a negative 0.12976, roughly 59 newtons. Okay, I'm going to store that in the letter I, just for fun. I'm just storing all these because I'm, really I'd use a spreadsheet if my TI calculator would let me do that. All right, so here we go. And then F2 plus F3 in component form is, all right, here we go. Okay, alpha C plus alpha H. This is in C, right? Here, let's just see. Alpha C. Yep. Alpha H. Yes, all right. Alpha C plus alpha H. Store that in M. This is 0.02497 newtons. It's a little bit, it's negative. Okay, there we go. I was going to say, because it's 265, which means it's to the left of 270. Okay, this is a good thing. Okay, so now let's go alpha D. Is that this? Yes. I'm going to go alpha I. Is this? Yep. Okay, so alpha D plus alpha I. I'm going to store that in the letter N. Okay, this is negative 0.30277 newtons. All right, so now I've got that, right? Okay, and now all we need to do is draw a picture of this guy, right? It's a little bit to the left and it's down, so let's draw a little bit to the left. And then from there, let's draw a lot of down. All right. And then the vector is there. Okay, this angle right here, the angle that's past 180 degrees, right, is going to be the inverse tan of 0.3027. That's this side, right? 27, right? And then this side is 0.02497. 24. Okay, now literally I'm going to just do second tangent of alpha n divided by alpha m because I have stored this. I'm getting 85.28 degrees. So if that's 85 degrees, of course the trig angle that goes all the way around is 180 plus 85, right? So add 180 to that. And that's how we get the 265. It's 265.28, right? And then the magnitude here is going to be the square root of these guys squared, right? So 0.024 0.97 squared plus 0.30277 squared. In my calculator, that's the square root of left parenthesis alpha m squared plus alpha n squared. Now, be very careful. If you're doing this on a TI calculator, remember that, in my opinion, it does not handle unary minus correctly. So don't make any of those minus. Or if you do, put parentheses around them. It doesn't matter, so just don't do it. But if you insist, you've got to put the unary minus inside of parentheses. Okay, so this is 0.3038 newtons is our magnitude. All right, so that's our answer right there. Right, there's our answer right there. I'm going to hit the erase button, and we can look at the direction of the forces on Q2. Okay. So on Q2, there's going to be a force of attraction that's that way, right? And then a force of repulsion, because this guy will be attracted to this guy, right? So there'll be a force of attraction that way, a force of repulsion this way, right? Okay. So this is going to be at, what is this angle here is 30 degrees, right? So this guy, this force 1 is at 60 degrees, right? This guy will be at 180 degrees. Now, it's all going to be in the x direction, the negative x direction. You don't need to use your trig angle, but if you can't step outside that constraint, why, there it is, right? Happy hunting.